All right, we're in section 11.1 where we're going to look at areas of triangles and parallelograms. So it doesn't matter which uh, which kind of triangle you have. It could be an acute triangle, it could be an obtuse triangle, it could be a right triangle. You're going to use the same formula for area for any kind of triangle, depending on what kind of angle measures they have. So it's going to be area equals 1/2 base times the height. So if you're looking at a right triangle like we have here, essentially it doesn't really matter which one is your height and which one's your base because of the position away it's basically your two legs are going to be represented by your height and base. So the only thing that you couldn't use is your hypotenuse. Now, when you have either an acute or you have an obtuse triangle, you have to make sure that whatever you choose as your base, you are making your height as perpendicular to that base. So in this case here, the height is going to be illustrated on the outside of this particular triangle. If you had an acute triangle, so say something like this would be your base. You would have your height would be illustrated on the inside. Okay, so just be mindful of that and be careful of you know orientation and stuff like that. Area of a parallelogram. Essentially, a parallelogram is just two triangles that kind of connect at their respective hypotenuse. So basically what I did was I just took this triangle here and flipped it over and just show you that it's just basically just two triangles, but it's essentially it's base times height. Uh, if you took an area of a rectangle, which is still a parallelogram, more specifically, they call it length times the width. All right, that's still essentially base times height in that case. If you had a square, which all of these sides are congruent, you're just going to take whatever the side is squared. So if you look at these individual examples, the first thing you have to state is, or you have to figure out is which polygon are they asking you to find. In this case, they're looking for area. So what we have here is a parallelogram, so it's going to be area equals base times the height. Well, the base is 25, the height is 15. Multiply those two together, you get 375, and since it's dealing with area, it's going to be uh, square units. Here we have a square, so the area is going to be whatever the side value is squared. So it's going to be 18 squared. So when you take 18 squared, it's going to be 324 square units. All right, below here we have a triangle. Now this is an example of an acute triangle. So you have to be careful with how it was, orientated and then figure out the base and the height from there. So area is 1/2 base times the height. This is our base because this line that is inside the triangle is perpendicular to that opposite vertex, so that's going to be h. So here it's going to be 1/2 base, which is 14, times it by the height, which is 22. When you multiply all those together, you get 154 square units. Now, there's some situations where they give you the area and they want you to find a certain value uh, in the shape, so looking for the unknown. So they're telling you that this particular shape has an area of 84 square feet. So they're giving us um, a triangle, so it's going to be 1/2 base times the height. So the unknown in this case is right here. So that's where our value of x is. So essentially, we're going to take 84, and it's going to be equal to 1/2 times it by the base, which is 21, times it by the height, which is x. All right, now there's a couple ways you can do it. One way is just multiply the 1/2 times 21, and you would get, your decimal of 10.5. If you're not a fan of that, you can multiply both sides by 2 to get rid of the fraction and then go about solving from there. But I'm just going to take the 21 and times it by 1/2. So now I got 84 is equal to 10.5x. And I'm going to take 84 and divide it by 10.5, which means that x equals 8, and it was square feet there, so it's just feet here. When it's like when we're dealing with base, when we're dealing with height, or we're dealing with length, width, stuff like that, side measurement, it's always going to be the singular units, not square units, and like that only deals with area. Here we have a rectangle with an area of 476 square meters. We don't have the width, so 476. Uh, Remember, this is length times width. It's going to be equal to the length, which is 28, and the width, which is x. So we just take 476, divide that by 28. We get x is 17 meters. Okay. Over here, they want us to find the area of the shaded region. So this first example, the whole thing is shaded. So it kind of looks like a front of a house, in a drawing of some kind with like the a a A-frame pitch of a house and stuff like that, and the roof and everything. So basically what you're going to do is you're going to break this up into two separate areas and then add them together. So like this top shape here is like area A, and this bottom shape here is area B. So area A is a triangle, so it's going to be 1/2 base, in this case from here to here, which is 25, times it by the height, which is 14. This is going to be added to the area of B. And so I guess they don't give us one. So let's just say that this is 10. So with that being 10, we'll say that this is 25 times it by 10. So we go over here. I multiply the 1/2, 25, and 14 all together. I multiply those out. We get 175. And then it gets added to 25 times 10. We get 250. And then we take the 175 and then we add it to the 250. And that gets us a total of 475. And that is square units because it's dealing with area. On this side here, we have this large shaded area as A, and we got this smaller one here, which is B. Okay, so the area of B is not shaded, so we're essentially taking that away from the area of A. So it's going to be essentially the area of A, which is a rectangle, which is length times width. So it's going to be 12 times it by 26, and it's going to be subtracted by the area B, which in this case is a square, and that's just going to be 5 squared. So 12 times 26, that gives me 312, minus 5 squared, which is 25. 312 minus 25 is 287 square units. Okay, and that is area of triangles and parallelograms. Hope this helps. Till next time.